Now we're ready to look at zeros of polynomial functions and all of the theorems that go along with that.
The remainder theorem. What this says is that if we have a polynomial, p of x, and it's divided by a polynomial of the form x minus c, in other words, that x has a 1 coefficient and a 1 exponent, then the remainder is the value we get when we plug in c into the function. For example, let's skip the factor theorem for a second. Let's go down to example 1. Use the remainder theorem to determine the remainder of that rational expression. Well, we are dividing by the form x minus some number c, and it could be a negative or positive. But in this case, that just means that my c is 2, and this top numerator is my polynomial that I'm dividing. So let's plug in 2 into that top polynomial. We will get 2 times 2 cubed plus 42 minus 4 times 2. And if you simplify all of that, we would get 50. That means if we were to divide that binomial x minus 2 into the top polynomial, we would get a remainder of 50. Now it says we can use synthetic or long division to confirm our answer. Let me remind you of both, okay? So down here below, we are going to use synthetic. Synthetic only works when your denominator is of that binomial form, just a single x plus or minus a number. So we take our c value of 2. Our polynomial there isn't in descending powers. So I'm going to write it in descending powers above. I would start with my 2x cubed. Notice there is not an x squared, so we would put 0x squared. And then the next one would be my x terms, my negative 4x. And then my constant goes last, the plus 42. This is important because in synthetic, we only use the coefficients, but all of them in descending powers. So it's almost like a backwards division symbol here. And I'm going to write all of those coefficients here on the top, 2, 0, negative 4, and a positive 42. So here's what we do with synthetic. We bring down this first number, whatever it is, it's 2, and then we multiply by that outside number and bring it back up. And we do that every single time. So this becomes a 4. And then we add the 0 and 4 and get 4. We multiply it by this outside 2 again and get 8. We add the negative 4 and 8 and we get a positive 4. We multiply that outside 2 and the 4 and we get an 8. And we end up with 50 as our remainder. And for those of you who haven't been that familiar with synthetic, what those other numbers means, the 2, the 4, and the 4, is those are the coefficients of the polynomial that's remaining after we divide. So since we started with a 2x cubed, this means we're left with a 2x squared, 1 degree down, plus a 4x, plus a 4, and with a remainder of 50 over our divisor, which was x minus 2. So that's synthetic division. Now, although synthetic division, again, only works when we divide by a binomial of the form x, single x, plus or minus a number, long division works for everything. So let's review long division. Our divisor is x minus 2. And we're dividing into, but we still have to put it all in descending power. So we have 2x cubed plus a 0x squared minus a 4x plus a 42. And then our goal with long division is we want to multiply this x by something so we would get exactly a 2x cubed. Well, x times 2x squared would give us a 2x cubed. So I'm going to put a 2x squared in my squared column. And then I'm going to distribute. 2x squared times x is 2x cubed. 2x squared times my -2 is a -4x squared. But now we have to subtract. So I have a little thing that I say, change the sign, draw the line, then combine. That way we don't forget. So if we've done it right, our first two terms would add up to 0, which they do. So those are gone. Our next two terms give us a 4x squared. And then we keep going. So we can bring down our other guys, -4x and plus 42. And then we look at our first terms again. X times what will give us exactly a 4x squared. We're missing a 4x. So I'm going to write that here in my x column, a positive 4x. And when we distribute, you get 4x squared minus an 8x. But now we have to subtract. So we distribute that negative by changing the sign, drawing the line, and then combine. So again, we get a 0. So those guys are gone. We're left with a 4x here, and we go ahead and bring down the plus 42. Once again, we look at our leading terms. I want that x to look exactly like a 4x, so we're missing a 4. We put that 4 here in the constant column and distribute. 4 times the x gives us a 4x. 4 times -2 gives us a -8. And then we subtract by distributing a negative to the bottom. So we change the sign, draw the line, and when we combine, we get a remainder of 50 again. So 50 over x minus 2. So you can consider those either reviews of the synthetic division or long division, or, hey, I've never seen that before. There you go. Now you know synthetic and long division. So remember, long division always works, regardless of if it's an x or a 2x cubed that you're dividing by. Synthetic, it has to be in the form of a single x plus or minus a constant. Now, the one thing about having a remainder of anything other than 0 tells us that x minus 2 is not a factor of that top polynomial. Otherwise, it would have divided in evenly. So that's where our factor theorem comes in.